Let's have a look at the results of our Pearson's R correlation from SPSS. And you can see here in our table, I've got ones across the diagonal, and that will always happen because it's a variable correlated with itself. So age correlated with age will always be perfectly positive, and the same thing here, our competency correlated with itself. So we never report these, we're just going to leave them alone. You'll notice that the other diagonal has the same exact information in both boxes, and that's because this is competency with age, and this one here is age with competency. So the exact same correlation. So we're going to just choose one of those boxes to report from. So if we have a look here, our first value is our Pearson correlation coefficient value of 0.228. Now, a correlation can be between -1 and +1, so it can be positive or negative. Our value is positive. And if we have a look up here at our scatter plot, we can see that when we looked at the relationship between age and competency, the older people were, the more competent they tended to be before starting the job. So this was an increasing relationship. Now there are a few extra dots here. These are kind of like outliers, but our general trend was upwards. So this is a positive one. Now we need to know how strong is that positive relationship. I would recommend either use your lecture notes or use the statistics book that you were given for your module or course to determine how strong or weak the relationship is. I'm going to show you a standard table that I took from a statistics textbook. So these values here for a positive relationship tell me what would be considered strong, moderate, weak, or none. And the same thing for negative values. So I can have a strong negative relationship, moderate negative, weak negative, or say no relationship at all. So if we go back to our SPSS output, our value of 0.228, that's going to fall into the weak category. So I have a weak positive relationship between age and competency. Now the next statistic is our significance value, also known as the p-value, and it's going to tell us whether or not we should conclude there is a relationship or not. Now, like with any statistical test that we do, what we're trying to establish is, did the results just happen by chance in our sample, or is there enough evidence to suggest that what we found exists in the population? So we found that looks like a weak positive relationship between age and competency. Did that just happen because of the employees we surveyed? Or would we expect to find that relationship existing in the population? So if we look down here at our p-value, 0.060, we're going to compare that to our alpha value. Now my alpha value is 0.05. Your alpha value might be different. For example, 0.01. Now this is bigger than 0.05. So that means I cannot reject my null hypothesis. And I have to say there's not enough evidence to say there's a relationship between my two variables. If this value was less than 0.05, or my alpha value, then I could reject H0 and conclude there is a significant relationship between my variables. Now, a common thing that happens that kind of throws students off is that you'll get a p-value that says 0.000. All that means is your p-value is very small, but it never equals 0. So never report that as p equals 0. And if you want to see an interpretation of a significant correlation, have a look at the video for interpreting a Spearman's R correlation.